All right, let's look at the molecular geometries that are based on 4 electron domains or tetrahedral electron domain geometries. What are the variations that can come off of it? So I've got 3 different examples here. In my first example, something like methane, CH4, we have 1, 2, 3, 4 domains. It is a tetrahedral electron domain geometry. Now, 4 of those domains are bonding domains. None of them are lone pairs. So if we have no lone pairs, we can see everything. If we can see everything, it looks like a chicken foot still. Since it looks like a chicken foot still, the electron domain geometry matches the molecular geometry. And we also say this has a shape that is tetrahedral, or molecular domain geometry is tetrahedral. Now, example number 2, ammonia, NH3. This still has 1, 2, 3, 4 electron domains. So it has a tetrahedral electron domain geometry. 3 of those domains are bonding domains, 3 bonds. 1 of those domains is a lone pair, gives us 4 total. When we look at the shape, we can't see everything. We can see the hydrogen, we can see the nitrogen, we can see the hydrogen, we can see the hydrogen, but it's like the lone pair is a ghost. It's ghosted out. We can't see it. So what's left over? Well, what's left over looks like a pyramid. It's a pyramid with a 1, 2, 3-sided base. So the molecular geometry is called trigonal for triangle base, pyramidal. Just one single pyramid, trigonal pyramidal. Okay, now as far as the angles, what's interesting is that the angle for a normal tetrahedron happens to be 109.5. But remember, lone pairs tend to spread on out. They're not bonded between 2 atoms. So that tends to squeeze those other atoms together. This angle, all you need to know is it's less than 109.5. It tends to be somewhere around 107. You don't need to know that angle. You just need to know it's a little less than 109.5. Now let's go through our last example of tetrahedral structures. Water, H2O. Water has a structure that has 1, 2 bonds, and 2 lone pairs, so 4 electron domains. Therefore, all of those electrons, whether we can see them or not, go into a chicken foot or tetrahedral arrangement. The electron domain geometry is tetrahedral. But what is the shape? The molecular geometry, if we just look at the things we can see. We can see a hydrogen. We can see a hydrogen, but we cannot see this lone pair, and we can't see the other lone pair. They're ghosts. They're still there taking up room. So what's left over is 1, 2, 3 things. But those 3 things are not in a line. Your line has been bent. This is a bent molecular geometry. So we have 3 different molecular geometries based on if we have lone pairs or not. Join me below and we'll do the variations of 5 electron domains.